In computer science, it's going to be super common for us to see this pattern. 1 plus 2 plus 4 plus 8 plus 16 plus ... all the way up to n over 2 plus n. So if I look at those, each term is twice as big as the last one. I could think about that as like 1 plus 2 plus 4 plus 8. Okay, here I've got a 16. Here I've got a 32. But let's look at this. When I have 1 plus 2 plus 4, I can put them together like that. And check it out. I've got the biggest term, the 4 in this case, is 1 bigger than all the other terms combined. And if I look at 1 plus 2 plus 4 plus 8, the biggest term is 1 bigger than all the other terms combined. And the case here, okay, 16, the biggest term is 1 bigger than all the other terms combined. If we use this one that like barely fits, we see the same thing. The biggest term is 1 bigger than all the other terms combined. That means that if my sum stops at n, then the sum of this whole thing is going to be 2n minus 1, because that n was 1 bigger than all the other terms combined. What if instead of having this sum, I had the same beginning, 1 plus 2 plus 4 plus 8 plus 16, we don't really need that many terms to see the pattern, 2 to the n minus 1, and then one that's twice as big as that, it would say 2 to the n. Okay, what would that sum be? There's the same relationship between each of the terms. Each term gets twice as big, and we'd have that same structure just like we had over here, where that last term is bigger than all the other terms combined. So all the other terms combined are 1 smaller than that, so we get 2 times 2 to the n minus 1. Or we can just write that as equal to 2 to the n plus 1 minus 1. Whenever we've got this structure, the biggest term, even if we put that, we flip it and we put it in the beginning, it's going to be the biggest term times 2 minus 1.